So on these problems, we are using synthetic division. On the first one, that's the only thing we're using is synthetic division to find the indicated value. So instead of doing long division, it can be easier to do synthetic division. So we're going to set up our problem. And remember that in this part, we're always looking at x minus c. And because in this case, we're actually given our value, we're just looking at putting in our -3. But in other cases, we will be careful to watch for x minus c. That would be the format. If they give it to you, you're just going to put it in the square. Now we're going to pull all of the coefficients down, including their signs. We'll have 2, -7, -5, and 11. We're going to draw our line. The first thing we do is bring down the 2. It's always just going to come straight on down. Some people like to draw arrows. You can draw them or not. It doesn't matter. So first number comes down. So 2 times -3 will get us -6. Now we add these together. -7 plus a -6. They're the same sign. We add and keep the sign. It'll get us -13. -13 times -3 is going to be +39. -5 plus 39 is the same thing as 39 minus 5, which will be 34. And it'll be positive because 39 is our bigger number and it's positive. 34 times -3 gets us -102. 11 plus a -102 is going to get us -91. So in this case here, f at -3 will equal -91. That's all you're looking for. You're looking for the remainder that happens at the end. All right, for our next problem, we're solving using synthetic division and the remainder theorem, given that 5 is a 0. So if 5 is a 0, that means we're plugging 5 into our synthetic division box. We're again going to pull down our coefficients, including our signs, 22 and 15. Drawing our line, we'll bring down our 2. 2 times 5 is 10. -15 plus 10 will get us -5. -5 times 5 is 25. And it's going to be -25 because we had a negative sign here. 22 minus 25 will get us -3. -3 times 5 is -15. 15 minus 15 is 0. Now when they give you a number like they did here, and it says given that 5 is a 0, you need to end up with 0 here. If you don't end up with 0, then you did something wrong, because if it is a 0, you have to get 0 here. At this point, we have 3 terms, so we can solve the rest of this by doing the AC method, or however you want to factor. I choose to use the AC method, so I'm going to rewrite this as 2x squared. Always drop down a degree, so we had a third. Now we go down to a second, minus 5x minus 3. So we are going to take our a times our c, so 2 times -3 gets me -6, trying to get to -5. So I start with 1 and 6, and we got to figure out who gets the sign. Because this is negative, the negative will be here because these signs have to match. So 1 times -6 is -6. When I add it, I get -5. 1 minus 6 is -5. All right, so there are the values I'm looking for. I rewrite my -5, so I have 2x squared plus x minus 6x minus 3. Break it into the 4 parts into 2. Over here I can factor out an x, and I get 2x plus 1. Bring down my minus sign, and I can factor a 3 out of both of those, and I get 2x plus 1 again, because -6x divided by -3 is 2x, and -3 divided by -3 gets us a positive 1. If these parentheses match, you did it correctly, and keep on going. If they don't, you need to go back and look at your signs. Sometimes you'll have the same numbers, but you messed up the signs. And group together the last part. So we're going to bring over our x and our -3. So now that we have those factored, we're going to set them equal to 0 to find our actual zeros. So we have 2x plus 1 equal to 0, and x minus 3 equals 0. Subtract our 1 over, we have 2x equal to -1, divide by 2, and x will equal -1/2. Add our 3 to both sides, and we get x equal to 3. So we have 3 zeros that we found. The first one is 5. The second one was -1/2, and the third one is 3. Make sure you always include the one that is given. Otherwise, you don't have your complete answer. And that is how you find your zeros for that one. The next one we're going to look at is we're going to use the rational zero theorem to list all possible rational zeros for the given function. So here is our function that we're given, and we're going to list them. Doesn't mean we're going to find them, we're actually going to list them. So to list the possibles, these are P and Q. So we are looking at taking the constant at the end, which is our 8, and we take the coefficient at the beginning, which is -2. And we are going to factor these. So they're always going to be plus or minus, because we don't know if it's the positive or the negatives that get multiplied together to get our numbers. So the factors of 8 are going to be plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So we can double check our work of 1 times 8 gets us 8, 2 times 4 will get us 8, and there's nothing in between those. So with -2, we're going to get plus or minus 1 and plus or minus 2, because only 1 times 2 will get us to 2. And again, you include your positives and negatives. Now to find our possible zeros, list all the possible zeros, we are going to take all of the numbers up here and put them over 1, and then all the numbers here and put them over 2. So we are going to get 1 over 1 will get us plus or minus 1. 2 over 1 would get us plus or minus 2. 4 over 1 is plus or minus 4. And 8 over 1 will be plus or minus 8. Now we're going to take each of them and go over 2. So plus or minus 1 divided by plus or minus 2 will get us plus or minus 1/2. 2 over 2, well, 2 divided by 2 is 1. We already have that one. 4 divided by 2 is 2. And 8 divided by 2 is 4. So if you're not quite sure what I'm doing here, you're basically taking the P divided by the Q. So you're taking the top number and dividing it by the bottom number is what we mean by taking it over. So this would be all of them, because the other numbers are going to reduce to ones that we already have, and we're never going to list them more than one time. And that would be all that you do for that problem.